So this is not a lightning talk, so please be prepared. Let's ask a question. How to build a fast database? Or why ClickHouse is fast? It is very difficult to answer this question because if I have to answer, I will say, there is no single answer. There is no single silver bullet. Don't even ask. Instead of trying to answer this question, I will do some hand waving. I will show you some principles, ideas, facts, beliefs, and so on. But I will mostly do hand waving. So if you want to build the fastest database, how to approach this task? You may say, I will use the best algorithms. But it is difficult because there is no such thing as best algorithms. But you still can try. First, you can choose the best programming language. What is the best programming language? C++ or maybe C? Maybe Rust, it is more modern. Maybe I will need to write in assembly because it is fast. And if I will write my database in assembly language, it will be faster than ClickHouse because ClickHouse is using C++, and you know C++ is so aged already. Okay, if I need to parse JSON, I will use the best library. What is the best library? SymJSON. Probably it is fast. I will use Apache Arrow to maintain data structures in memory. I have read on the internet that Apache Arrow is a good library. I will use memory method files, or no, I will make my database in memory because memory is faster than disk, and ClickHouse is not in memory database. And if I will write in memory database, it will be faster than ClickHouse because memory is fast. I will use asynchronous framework because you know what? Asynchronous should be fast, maybe. So probably it will be faster than ClickHouse. But actually it's not enough. If you will use all these principles, it probably is a bad idea. Let me show you one example. How to process JSON data quickly. Let's use the best library, SymJSON. Yes, SymJSON is the fastest library to parse JSON. If you are not sure, look at this guy on the right. Look at his face. He cannot be wrong. He has written this wonderful library, and he is responsible for this. And ClickHouse is using SymJSON. And recently, there was a benchmark about command line tools to do queries on JSON. And this benchmark compared multiple tools like JQ, DSQ, TRD, SQL, Spark, SQL, Midler, SpikeQL, OctaSQL, and ClickHouse. There is a link, and unsurprisingly, the best performance is shown by ClickHouse. And also OctaSQL, it's like similar. And ClickHouse is using SymJSON, and obviously it should be the reason of high performance, but actually it isn't. So ClickHouse is using SymJSON. It is the fastest library. But it is using SymJSON in a different context. We don't use SymJSON to parse incoming data, to parse source data, to parse input. We use something different. So the question is, did we actually beat SymJSON in speed? The answer is, it's complicated. Yes and no. And the reason why ClickHouse can process JSON faster is not that we use the best JSON parsing library. It's because we don't actually parse JSON. Instead, we just read first records. We learn the structure from these records. And then we use this structure to read JSON without actually do full-featured parsing. We don't need to really use full-featured JSON parsing library. You know, there is old Chinese poetry saying, if you want to parse JSON faster, you don't need to parse JSON at all. So use Chinese poetry and you will write fast code. Another observation. Every algorithm cannot be just fast. It makes sense in its own context. Let's take this example. I want to use the best hash function. What is the best hash function? Let's go to the internet and write a search query, fast hash function. And you will have overwhelming amount of results. OneGu hash, the fastest quality hash function. What does it mean? XX hash, extremely fast hash algorithm. If it is named XX hash, it probably has to be extremely fast hash algorithm. Aqua hash, fast hashing, just fast hashing, but at least they have some pictures, and it is very difficult what to choose. You have to consider where are you going to use this hash function. You can just implement it in SQL. So people will write, select my best hash function or something. You can use it in hash tables. So it will be used when you do group by or join. You can use it inside Bloom filters. And every context is different. And what is even more paradoxically, imagine you will use this hash function in SQL, and your users will be able to write, select my best hash function from table. And this query will be fast. But you cannot longer use the same hash function for hash tables. Imagine that your users will write like this, create distributed table, distributed by remainder of division of this, the best hash function. And then the user will write a query group by X. But on every server, the lowest bits of this hash function will be unused because data is distributed by this hash function. So if you expose hash function in SQL, you cannot longer use it inside hash table. Too many details, too complicated. Okay, I have even more complicated slide. So, what is the best hash function? You have to look how it was tested. And there are multiple possible mistakes in testing hash functions. Imagine you will test it on strings of size 10. It is not enough. You have to test on every string size. On size 1 byte, 2 bytes, 100 bytes, and so on. Even on empty strings, it also makes sense. But it is also not enough. Actually, you have to test hash functions on different random distributions of sizes. Because if you will write a loop, and inside this loop, you will process the strings of the same size, you will make CPU branch predictor to do too easy work. It will be not stressed enough. The distribution will be not realistic. So you have to test on real data sets. It will be better. you have to ask, what if my data set has 90% of strings of size 0? And this hash function has to work well on this case. What if most of the strings under 100 bytes, but 1% of strings are exceedingly large? It should also be tested. You should, okay, I will not dig into all these details. But you have to always dig into details. If you want to build the fast database like ClickHouse, you don't have to. Let me show you one example. How many times you just load some website on the internet and the page has loaded in 5 seconds. So something is wrong. You hit refresh, you check again, and it is loading instantly. So everything all right. Probably it's a temporary glitch. It does not reproduce, so why even bother? But this is the wrong way. The right way is to ask yourself, why this particular my precious query was processed in 5 seconds? Let's find this single query in the logs. I don't care if million other queries processed quickly. I only care about my query. I expect that if you will write a support request, why your website loaded in 5 seconds, they will just answer you. We tried to reproduce, the problem does not reproduce, so forget about it. But if it is your website, you can look at the logs and figure all the details. So, another example. I have tested ClickHouse Cloud. I have tested queries using object storage and local file system. And in most of the cases, queries from object storage is not significantly slower, at least not more than 1.5 times. But in some cases, I see random latency spikes. So some queries are slower like 40 times. And this should not happen. If I just try again, different queries will be slower 40 times. But I have every logs in ClickHouse, and I can do this query to get query metrics and to compare query metrics. And it will look like this. And the reason became obvious. A slow query is reading 2 gigabytes of data from disk, and on these servers we used to have very slow EBS volumes. So it is pretty easy. You only have to look in the logs. Another example and recommendation. So if you want to figure out why some query was slow, you have to do always on profiling, always on telemetry and introspection of your system. And we have plenty of options inside ClickHouse. We have a debugger like GDB embedded into ClickHouse. You don't have to install GDB. Just select from system.stacktrace, and it will show you where currently every thread is running. We are recording this data into another table, system trace log. It is sampling query profiler that you can use to draw flame graphs aggregated by multiple servers on the cluster for a period of several weeks. Or even you can get and look at one single query. And obviously we have query log, and we have all the metrics, including CPU-related metrics. So you want to know how many branch mispredictions was in your query. And you will see I have so many branch mispredictions. Probably I need to say, user, you have a wrong query. Rewrite your query. You can get this information from system query log. And what to do if you want to entertain yourself on Friday night. By the way, I assume you don't have family. First, run your program under a trace and explain everything that it will show. When you explain everything, you can go to sleep. On Monday. Second, just attach with DDB and look at the stack traces. And again, explain everything you see. Run sudo perf top and look at the assembly. Even if you don't know assembly language, it looks beautiful. If you run a query and it takes 1 second, ask yourself, why not half a second? If you optimize it and it runs in 1 millisecond, ask yourself, why does it take a whole millisecond of time? 1 millisecond of time wasted. For what? You have to optimize. Okay, the next principle. Always design for production workloads. You cannot build a fast database management system sitting in some auditorium in University of Database Engineering, Minnesota. I'm not sure if this university exists. Probably not. But if you do, your database management system will be fast, but only on paper that you will write and submit to some conference. Instead, it is better to always be close to production, optimize for real production workloads. The more diverse workloads, the better. And do quick iterations, do quick releases. So you have to absorb the changes and react accordingly. By the way, this is the logo of one research system. I like this logo. About benchmarks. I like benchmarks. Some people collecting stamps, I collect benchmarks. Here is a link about every published benchmark for ClickHouse and how to approach benchmarks. You can make your official benchmark when your system is obviously better, but maybe it will not be very credible. Instead, it is better if all people on the internet will do benchmarks for you. And if your system will look better on these benchmarks, it will mean something. But not everyone likes benchmarks as I do. When I read acceptable use policy of some system, I found this. You may not use the offerings in order to benchmark offerings or to build similar or competitive products and services. By the way, they updated the terms of service. Maybe somehow they read my presentation. Okay, so my advice, do benchmarks, do more benchmarks. Don't prevent others from doing benchmarks. Don't do benchmarks. Let your users do benchmarks. Always continue experimenting. So, you know, ClickHouse is already well optimized, but can we optimize it even further? We can try multiple ideas, but you should expect that most of the ideas will not work. You have to select hundreds of ideas, you have to try all of them, and maybe one of them will work. One example, optimizing hash tables for group by. I tried prefetch. I tried SIMD instructions for lookups. I tried Robinhood hash table algorithm and even Swiss tables from Google. I tried to allocate more memory after the space in hash table to avoid wraparound. Difficult to explain. Yeah, I promised hand waving. But one idea worked to predict hash table size in advance. So we collect statistics about to what point hash table will be resized. And we learn from these statistics and reuse it. And it makes a huge difference. So one idea worked. Another advice. Rewrite code all the time. Don't worry, don't be afraid. And let automated continuous integration do the testing for you. You have to do automated performance test, integration test, fuzzing, and sanitizers. If you write code in C++ and you don't use sanitizers, your code is not good. And what about automated performance test? It is important not to only optimize one query and show that performance is optimized 50% on this scenario. It's always important to ensure that it does not decrease performance for every other query. What if you optimized one obscure scenario for 50%, but everything else degraded by 1%? It should not be approved. One example from my colleague, he asked me to put this slide into presentation. One of the most recent optimizations in ClickHouse. Optimization of sorting with just-in-time compilation. It was 5 seconds, and if I enable it, it is just 4 seconds. Plus 30% performance improvement, so thanks to Maxim. What else? How does automated performance testing look like? It looks like this. One contributor, Raul Marin, has optimized aggregate function sum with some batching or SIMD instructions or newer CPU instructions. And we see that yes, queries are optimized 1.5 times. He don't have to prove. Our continuous integration system proves for himself. Another advice. Test at scale. Test on overload. Test until it will break. And how to do this? I know ClickHouse works fine on databases of 100 trillion records. This number is difficult to imagine. It is even larger than the national debt of the United States. 1 and 14 zeros. And your tests should also run at scale. But it will be very difficult to load 100 trillion records on every test run. It requires hundreds of servers, hundreds of petabytes of uncompressed data, but at least tests should run at scale. One example, there is public dataset, Wikipedia page view statistics. It is available in public domain by Wikimedia Foundation, and it has 370 billion records, containing 1 billion of time series, page views on every article. I loaded this dataset into ClickHouse almost instantly after I noticed that this dataset exists. Then I loaded this dataset again. Then I loaded it in 10 different ways. I have loaded it into merge tree table, into replicated merge tree table, into replicated merge tree table on replicated database. I have loaded this data into S3, and I have loaded this data from S3 into ClickHouse. I have tested our ClickHouse cloud with this data set. And now ClickHouse eats this data set for breakfast with a speed of 40 million records per second. This is not me. Don't worry. But he looks very similar. Do weird things. Do weird stuff. You have to do weird stuff to challenge some beliefs. What are common beliefs about ClickHouse or misbeliefs? So ClickHouse probably is not good at loading large binary data. But what will happen if I will download about 5 million websites from the internet and upload these HTML pages into ClickHouse? And I did exactly this, and it went all right. So ClickHouse is probably not good if you do insert directly from JavaScript from web page. But I did exactly this. I built a service like Pastebin, and more importantly, I persuaded all my colleagues at work to use this service. And it went all right. Here is the service, pastilla.nl. What will happen if I will use URL table function to do 10 million HTTP requests? I tried. It did not go all right. But we have fixed it. And now you can do this. So ClickHouse, you know, ClickHouse is not good as key value database. That's true. ClickHouse don't want to be a second MongoDB. ClickHouse is probably not good as a streaming data processing system. We are not Kafka. ClickHouse is not good as a search engine. We are not Elastic. And I'm happy that we are not similar to Elastic, by the way. ClickHouse cannot be used for search in vector embeddings, so machine learned search. But hold my beer and read the roadmap for this year, 2022. You will find many of these things that probably will be possible in ClickHouse in this year, or the next year, or 1 year later, but still, I want to do weird things and test what will happen. And the most importantly, why this picture is not animated? Why this picture? It should be animated. The most important is to have fun. You have to always have fun if you are software engineer, if you write C++ or even x86 assembly, you will always have fun. But the basic principle is do whatever you want if you can drive some conclusions and debunk some illusions. One example. I have loaded the first trillion prime numbers into ClickHouse. For what? I did not even ask this question. And the idea has no direct application. I just want to do this. And if you want to build a service displaying prime numbers, there is more optimal way to do this. But nevertheless, I have tested ClickHouse Keeper, a replicated merge tree with object storage and replicated databases, and everything inside ClickHouse Cloud. And I have these observations. Everything worked perfectly. And one was the final. So how to have fun? Do you recognize this query? What it is? Yeah, it is FizzBuzz. Is it fast? What query is faster, this or this? And how fast is it? I will not give you the answer. I advise you to try by yourself. You should always have fun. I don't want to steal everything from you. So, what are the takeaways? How to write a fast database management system? You have to use good algorithms in a good context. You have to look into every detail, measure everything, work close to production, do benchmarks, do more benchmarks, never stop experimenting, test at scale, do weird stuff, and have fun. And my advice, get alive. Start contributing to ClickHouse. So, questions about how to make a fast database?